Hi, Mackenzie. This is Kadrian again. And I saw this question about Australia's square mile area, and it's asking for the number of people per square mile in Australia. So this is really interesting. You can see that they use scientific notation, just as we discussed in the last in your last question, to define and measure this really big number, because we're talking about the area of Australia. That's a lot of square miles. So they use scientific notation to express that. But the question is, what is the approximate average number of people per square mile in Australia? And they want us to round to the nearest person because, well, we can't have half of a person or a fourth of a person. We can only have whole people. So there is some information missing from here, and that's because we don't even know how many people are in, the area, the total area that they gave us. So how could we know how many people are in just 1 square mile? So we have to find out how many people are living in this 2.95 times 10 to the 6 square miles of Australia. So, you can find that with a quick Google search. I Googled it, found the 2020 population to be 25.5 million. And that's a lot. In other words, that's 25,500,000 people living in Australia. Okay, so we do not want to do math with, we don't want to do math with this large number with all the zeros. So we're going to do what the question did. They didn't want to use that large number for square miles to show us the area of Australia. We don't want to do that with population, so we're going to use scientific notation too. And so how do you write a large number in scientific notation? How do you notate that with scientific notation? So basically what you do, this is how scientific notation works, is the decimal is here at the end of this last zero here, all right? And you're just going to move it back. So if I move it back 2 spaces, then I'm going to multiply that number by 10 squared. If I move it back 3 decimal places, I'm going to multiply that by 10 to the third, 10 cubed. So for example, here in our area, we've got 2.95 times 10 to the 6th. That means that this decimal, we're right after the 2. Really, in reality, the decimal is 6 places to the right of where it is now. So really it's, if we write it out, let's see, really we start off with 2.95. We're going to move that decimal place over 1, 2, 3, 4, 5, 6. Make sure that's right. 1, 2, 3, 4, 5, 6. Yep, that's right. Really, that is 2,950,000 square miles. But we don't want to deal with those really large numbers. So we're going to put the decimal back to where it was, 6 places to the left. 1, 2, 3, 4, 5, 6, and leave it how they have it. We're going to do the same thing with the population. And when you do that, you're going to get 2.55 times 10 to the power of 6. So why did we move the decimal 6 places back in our population? Well, because it's going to make our math a lot easier. Remember in the last video when we talked about like terms? If we only moved our decimal place back 5 places, and so we have 25.5 times 10 to the 5th, it would make our math a lot a lot more difficult, and we'd be doing unnecessary work. So always try to match up with the question. You know, you see they're using 10 to the power of 6. Try to do that as well when you can. Like terms are your best friend. Like terms, see? Okay, so now we know the population. Now we know how many people are living in this 2.95 times 10 to the 6 square miles in Australia. Now we can kind of see, we can use math to see how many people are in just 1 square mile. And what this is called is a ratio. So that's what we're going to do right now. We're going to set up a ratio. So let me move this out of the way. I'll move this here. Get rid of this. So our ratio is going to be this. I like to start off with what we're looking for. We're looking for how many people are in 1 square mile. I have X people per square mile. So how many people, oops, 1 second. Let's write that again. So X people, I'm going to move that so you can see it above the line. And in the denominator, we're going to have 1 square mile. I'm going to go into the full board so you can see the whole board. This is a ratio, so ratios have to be equal to each other. So we're saying how many people are in 1 square mile? Well, we're going to find that out if we set it equal to, we already know that there are 2.55 times 10 to the 6 people. We already know that we have that many people living in 2.95 times 10 to the 6 square miles. It's really important that you keep your units because if you're doing something a little more challenging with a lot more math, you might forget or lose sight of what exactly it is that you're looking for. And a lot of teachers, they do like to grade work based on if you've used the right units or not. You can get something, you might have the number right, but your units were wrong, so you didn't get the points. Don't want that to happen. So always include your units. Okay, so now we have a ratio. Ratios are equal to each other. So we have to solve for x, and we're only going to be able to solve for x if we do some math, pretty much. So this is over 1. We can basically just ignore that 1. This is the same thing as x is equal to 2.55 times 10 to the 6 divided by, I'll use the line to do the divided by because it's a lot easier to look at, divided by 2.95 times 10 to the 6 square miles. Or, yeah. So let me get this under here good so you can see it. And then I'm going to write our units in blue. So there's units on both sides of the equation. People per square mile. Just make sure you have it here so you know where you are. Like, and you know how many or what the units are. Okay, so now we can just do the straight math. Remember, we're looking for how many people per square mile. So we've got 2.55 times 10 to the 6th divided by 2.95 times 10 to the 6th. This 10 to the 6th here, it's basically going to cancel out. And I'll show you why. It's going to equal out to 1, and I'll show you why. So this goes back to like terms, combining like terms. So remember when we have 4x plus 4x, you can add those to get 8x. That's combining like, that's one way of combining like terms. And then you have fractions. If you have 4 divided by 4, that's 1. You have x divided by x, that's also 1. These things just kind of cancel each other out, okay? Anything divided by itself is just 1. So knowing that the 10 to the 6th divided by 10 to the 6th is just 1, because anything divided by itself is just 1. So that makes our lives a lot easier. And now all we are left with is, and I'll write it here on this new board. Here we go. Let's go back to black. All we have left is x equal to 2.55 divided by 2.95. Remember, our unit is people per square mile. People per square mile. So I'll take calculator. Let's take the calculator and find out what 2.55 divided by 2.95 actually is. Okay. So I have my calculator out. 2.55 divided by 2.95 is, and you get 0.8644. Okay, 0.678. Now, you can't have point of any type of person or anything like that. The reason why it's a decimal is because we took out that 10 to the power of 6, right? So we can actually put that back in. If this was normal math and it was just a normal number and you're just having to solve it, you would cancel this out. But because we're using that as a notation, that's right, you can't take it out. You have to leave it back, leave it in there. So we're going to put this back in. Okay, so we're going to put this back in. So go back to this equation here. So we're actually going to have the times 10 to the power of 6 here. We can keep what we got on our calculator, the 0.8644. We can keep that, okay? So we're going to do 0.864. So x is equal to 0.864 times 10 to 6 people per square mile. Okay, because we said 2.55 divided by 2.95. We got that as 0.64. Now we have to add on that scientific notation, because remember, we were just using those decimal numbers so that we could use scientific notation to describe a really large, big number. Okay, so now we can actually round up, because there's no such thing as 0.8 of a person. Okay. So let's see what this number actually is. Let me move this out of the way for you. So let me get this. Here we go. Before we round up, I want to show you what this number actually is. To find out what this number actually is, we would move this decimal out. Okay, so we're going to move it out how many places? 6 places. So 1, 2, 3, 4, 5, So this number expanded out, actually, let's see, what is this? 864,000 people per square mile. Now, the reason why we didn't round up here, so let me get out my text. So, not round here, you may be asking. Why not round right there? Because we've got, our final answer with, the notation. So if we were to round this 0.886 to 1, because, you can't have an eighth of a person, that would be 1 times 10 to the power of 6. We would have gotten 1 times 10 to the power of 6. And that is basically, we're going to have to move the decimal place 6 places to the right. 0, that's 1, 2, 3, 4, 5, 6. That is a million people. You see how far away a million is from 864,000? So our answer would have been off by a lot because of, the scientific notation, the 10 to the power of 6. So it's best to write out this full number, expand it, and then round at the end. And that's why we didn't round there. That's why we rounded at the very, very end. So you're going to keep your scientific notation in the ratio. When we were doing this work here, the ratio work, and we got this here, keep it there, because that's going to, like you saw, like we did just now, that's going to help you expand that number out. After we do that math, it becomes a lot easier to look at. And yeah, that's how many people you have per square mile. 864,000 people per square mile. So let me know if you have any questions. Also, let me know if I went too fast or if I went too slow, or if there's anything that I did that you're not understanding. Definitely ask me, and I'd be more than happy to follow up with some more explanation. But I think this is pretty good. But still, let me know if you have any questions. Thank you. Bye.